Hello everyone. Today we are going to discuss the session 11 of chemistry paper 3 in the analytical chemistry part of third semester BSc chemistry syllabus. This unit consists of the chapter 1 of analytical chemistry, and this session includes brief introduction about the filtration, ultrafiltration, zone refining, and the principles involved in this. The learning objectives of this session is to understand the basic principles of filtration, ultrafiltration, and zone refining. And the session outcome is the students can understand and learn the meaning of filtration, ultrafiltration, and zone refining, and students will understand their principles. Filtration is basically a physical, biological, or chemical operation that separates solid matter and fluid from a mixture with a filter medium that has a complex structure through which only fluid can pass. The common separation method based on the simple principle is that materials smaller than a certain size pass through the porous filter and larger do not pass. The terminologies involved in this filtration part is what passes through the filter paper is called as filtrate, and what is caught on the filter is called as retentate. And the components of this experiment is a filter and a support such as a funnel, a vessel to receive the filtrate, a driving force such as gravity or vacuum. The basic principle of filtration is that the volume of filtrate collected per unit time is given by dV by dt is termed as the rate of filtration. As the filtration proceeds, the solid particles accumulate on the filter medium, forming a packed bed of solids called filter cake, and it can be observed that as the thickness of the cake increases, the resistance to the flow of filtrate increases and the rate of filtration decreases. If the rate is maintained to be constant, then the pressure difference in the driving force, that is minus dV, will increase. And the second part is ultrafiltration. It is a variety of membrane filtration in which forces like pressure and concentration gradients lead to separation through the semi-permeable membrane. Unlike in the filtration, here in the ultrafiltration process, we are using a semi-permeable membrane. And the ultrafiltration can separate the high molecular weight substances, colloidal materials, organic polymeric materials, inorganic polymeric materials, etc. This separation process is used in industry and research for purifying and concentrating macromolecular solutions of the molecular weight up to 10 to the power 3 to 10 to the power 6 daltons, especially the protein solutions. It is very useful in the separation of biological molecules like proteins. The important principle involved in the ultrafiltration is the suspended solid and solutes of high molecular weight are retained in the retentate and water. The low molecular weight solutes pass through the semi-permeable membrane in the filtrate. That is, the basic operating principle is a pressure-induced separation of solutes from the solvent through a semi-permeable membrane. As I said here, in the ultrafiltration, what happens is the particles, will be settled on the filtrate here on the semi-permeable membrane. Only the solvent can pass through the semi-permeable membrane. The relationship between the applied pressure on the solution to be separated and the flux through the membrane is given by the Darcy equation, that is J is equal to T into M into P divided by mu into RT, where J is the flux, that is flow rate per membrane area. TMP is the transmembrane pressure, that is pressure difference between the feed and the permeate stream, and mu is the solvent viscosity. RT is the total resistance, that is sum of membrane and fouling resistance. The next part is the zone refining. It is an important principle for the separation of many of the substances, and it is also one of the separating techniques, just like filtration and ultrafiltration. The zone refining is a method of purifying a crystal wherein a thin region of crystal undergoes melting. This molten zone is now moved across the crystal. This is the fundamental principle of the zone refining. And zone refining is actually based upon the fractional crystallization, as the impurity prefers to stay in the melt, and on solidification only pure metal solidifies on the surface of the melt. What you can understand is zone refining is based on the fractional crystallization, as the impurity prefers to stay in the melt, and on solidification only the pure metals solidifies on the surface of melt. It is an important thing, you must have to remember this. Zone refining is a very useful method to get metals with high purity, such as silicon and germanium, which are very important metals. Such metals can be purified by using the zone refining method. The principle involved in the zone refining is that the impurities in a block of metal or ore of metal are more soluble in the molten state when compared to the corresponding solid state of impurities. What you can understand is, the basic principle is that the impurities in the block of metal or ore of metal are more soluble in the molten state when compared to the corresponding solid state of the impurities. In the zone refining process, the impure metal is heated with the help of a circular heater. At one end of impure metal, the molten zone is moved forward along the impurities and reaches the other end and is discarded. Okay, what is that? The impure metal is heated with the help of a circular heater at one end of impure metal, and the molten zone is moved forward along with the impurities and reaches the other end where it is discarded. Okay, the different component of mixture are differently adsorbed on the adsorbent. Which is the adsorbent here? It is actually the malt of the metal. Then the impurities are concentrated at one end of the block of metal so that the rest of the block is purified. Impurities of low boiling metals can be separated by distillation. Pure metal recrystallizes out of the melt. Okay, that is, the impurities are concentrated at one end of the block of metal so that the rest of the block is purified, and impurities of low boiling point metals can be separated by distillation, and the pure metal crystallizes out of the melt. So in recap, we can recall what we have discussed is the filtration separates solid matter and fluid from the mixture. Okay, here what we can do is we can separate the substance which can settle on a surface, and the solid matter and the fluid in a mixture can be separated out by using this method. And ultrafiltration is basically a membrane filtration method. Particularly we are using a semi-permeable membrane. Okay, and the separation is done by a force of gravity or by the force of a pressure. And the next one is the zone refining, refers to the method of purifying a crystal based on the principle that impurities are more soluble in the melt than the solid state of the metal. Okay, in zone refining what we are doing is we are heating the metal on one end, and it is the substance to be separated, that is a metal along with the impurities, are carried along the metal from one end to the other end, and they are absorbed on different zones of the metal, and on the other end the impurities are separated or crystallized so that the required metal can be separated out from the mixture. Okay, so this is how you can understand the filtration, ultrafiltration, and zone refining. And the instrumentation of zone refining we shall discuss in the coming sessions. Now let us look at a few questions based on the topic or session which we have discussed. The first question you can ask is, what do you mean by filter cake? You have four options: the cake which is to be filtered, a porous membrane used to retain the solids which are present on the filter, a suspension to be filtered. You have four options, and the correct answer is the solid which are present on the filter, that is option C. The explanation you can give for this is the filter cake is usually the insoluble matter which is left on the filter. As the cake grows, the particulate matter is retained, resulting in the thickening of cake. Okay, so this is the first question which is related to the filtration. And the second question is, in ultrafiltration, dash is used: a permeable membrane, highly permeable membrane, semi-permeable membrane, or a non-permeable membrane. Your answer is C, that is semi-permeable membrane, because in the ultrafiltration, separation through a semi-permeable membrane happens. Water and low molecular weight solutes pass through the membrane in permeate, while the suspended solids and solutes of high molecular weights are retained on the surface of the semi-permeable membrane. And the third question is, zone defining is based on the principle that dash. The option is option A, impurities of low boiling point metals can be separated by distillation. Impurities are more soluble in molten metal than in the solid metal. Different components of mixture are differently adsorbed on the adsorbent, and the vapors of volatile compound can be decomposed in a pure metal. And the correct answer is B, that is impurities are more soluble in the molten metal than in the solid metal. And it is because the zone refining based on the fractional crystallization, as the impurity prefers